Hi all, welcome back to our YouTube channel. Topic that we will have a look at today is from FRM Level 1 and it's from paper 2, that is Quantitative Analysis, and topic is hypothesis testing. Before we go ahead, please do subscribe to our channel, comment, like and share with your friends who are preparing for FRM Level 1 exam or in general uh, with your MBA colleagues also, because hypothesis testing is a topic that is very common to all the curriculums we have in finance. And yes, at our institute, we try to stimulate your thought process, which will eventually enhance your learning. So, this was a query that was asked in one of the forums. So, we will understand hypothesis testing with reference of this example. Let's see, and accordingly, I will give you some more background about hypothesis testing, and we will apply it to this question. A manufacturer of car claims that average life of the car is 6 years. We took a sample of 10 cars. So there is a car manufacturer who's very confident that he's producing cars which have average life of 6 years. So to understand his statement, what we did, we took sample of 10 cars. Let me just keep underlying things. So it is a claim by manufacturer. So to verify his claim, what we did, we took 10 cars, which gave, so from that sample, we saw that average life of the car was 5.4 years, whereas the claim from the manufacturer was 6 years. And our sample, that was 10 cars, had a standard deviation of 2.2 years. So like standard deviation as in like you can have, there would be few cars which would be higher than this mean, and there would be few cars which would be lower than this mean. That's what this standard deviation means over here. And from past experience, it is known that standard deviation of all cars manufacturing by manufacturer is 2.5 years. So this is a population standard deviation. So this 2.2 standard deviation is for this sample of 10 cars. And this 2.5 year standard deviation is a standard deviation of the population, which has been given to us from the past experience. Test at 1% significance whether the average life is significantly less than claim of 6 years. So we are asked to do hypothesis testing if the average life is significantly less than 6 years. So this is what we have to test. So it's try to understand it from the broader perspective. Uh, it's common, right? Car manufacturer would be very confident about his product. He would claim superiority of his product by saying that average life is more than 6 years. And we being customer, we can counter his claim and we can say that no, it's less than 6 years. So that's what we have been asked to verify. Whatever claims being a customer we are making has to be verified at a 1% level of significance. Let's see how we do it. So before we go ahead, just try to understand how this, what exactly is hypothesis testing. So in statistics, there are two major branches. One is descriptive and another one is inferential. So when I say inferential, it's a tool wherein you arrive at some conclusions. Like hypothesis testing is a classical example, wherein using the tool of hypothesis testing, you arrive at a meaningful conclusion. Whereas descriptive is something which is just for description, like if you have got classroom wherein you have got both boys and girls, so distribution of that boys and girl is just a descriptive. You're not making any decision based on that information. So that is a descriptive statistics. Whereas this hypothesis testing falls under the branch of inferential statistics. And this is a definition of hypothesis testing. It is a statistical method used to make inferences and draw conclusions about population parameter based on the sample of the data. Like I would say that in this example, like a car manufacturer was claiming about his entire population, and we took sample of 10 cars and we were trying to understand if the claim of the car manufacturer about his population is correct or not. That's how the hypothesis testing is used. So let me just jot down in short the steps in the hypothesis testing. So there are four steps broadly in hypothesis testing. First, you formulate the hypothesis and then choose a level of significance in questions usually you will be given, and calculate test statistic and make a decision. And it may appear very I mean, it may not, you may not follow it completely at this point, but we will explain you through the numerical question that we had in the previous slides. So this was a given information wherein car manufacturer was claiming about population that my average life has more than 6 years, and when and to counter his claim, we took sample of 10 cars, and the mean of those 10 sample cars was around 5.5 years. In fact, it was 5.4 years. And the standard deviation is 2.2 years for sample of 10 cars. And the standard deviation for the population from the past experience that we have been given is 2.5 years. And level of significance, that is alpha. See, alpha is basically nothing but what is a so so just to give you an example, if I'm a portfolio manager or you are a portfolio manager, you claim your investor that your portfolio will give you return more than 10% with confidence of 95%. So you are 95% confident that your portfolio will give return more than 10%. That means there is a chance of 5%. So 90, you are 95% confident. There is a scope of 5% that it may not give you returns greater than 10%. So that's the alpha. So 5% is a alpha. Don't get confused. Alpha used in portfolio management and alpha used in a hypothesis testing. Alpha used in a hypothesis testing is just for a level of significance, which is 1 minus confidence level. So over here, we want to test our hypothesis with a level of significance 1%. That means we have to be 99% sure on our hypothesis testing. So let's formulate the hypothesis using the steps that are given on the left side for the numerical that was there in the previous slides. So null hypothesis and alternate hypothesis. So it's a very simple thing. We want to claim, being a customer, as we saw that we want to test hypothesis at 1% level of significance that average life is less than 6. So this is my alternate hypothesis, which I want to prove being a customer, and negation of that would be a null hypothesis. Okay, so whatever you want, researcher wants to prove would be alternate hypothesis, and negation of that would be null hypothesis. And we have been given level of significance as 1%, so no need to choose, but we are given in the question. Now, very important, to test hypothesis, you need to have you have some tools, like in this case you have been you know the population standard deviation. So population variance is known, and sample size is less than 30. That is, our sample size is 10. So we can use the Z test. Okay. So again, if this population standard deviation would not have been given, then perhaps we would have used the T statistics. So, but over here, we are good to use the Z statistics. So this is how you calculate Z calculated. So you uh, take your sample mean minus your hypothesized mean. So this mu comes from the hypothesized mean, and this is from your sample. So 5.4 minus 6 over the population standard deviation, that is 2.5 years, under root n, that is sample size. If you do this calculation, you will get negative 0.7589, which is approximately equal to negative 0.76. So this is a important parameter that will help us deciding or taking a decision on our hypothesis testing. Let's see how we do it. So making a decision, see now the use of level of significance will come into the picture. So we have been given 1% level of significance. So we need to know that what is a Z score corresponding to this 1% probability. So this is my level of significance. So we will go to Z table of the probability, and we will notice that 1% probability is over here, and Z score corresponding to that, it's 1% is between these two. So Z score corresponding to these two would be 0.233. So it's between somewhere here, but yeah, we can take it approximately. So this is called as a Z critical. So now you have two things, that is Z critical that has come from the table, and this is what you calculated. And decision criteria would be, if your Z calculated would have fallen in this shaded zone, then you can reject null. But given this Z calculated has fall in this white zone, we are failed to reject null. Okay. So what does this mean? Our null, so our null was that our mu is greater than equal to 6, and h1 was mu is less than 6. So we don't have a sufficient evidence to reject this. Somewhere, I mean, if you were to explore it more, we are unable to reject this. We have failed to reject null hypothesis. It means somewhere manufacturer is correct. At 99%, we are not able to reject this null hypothesis. So this was about one tell test, but in practice or in exam, you may have two tell test also. So in a similar way, do the Z calculated or T calculated. If you fall between this white zone, you fail to reject null. And if you fall in this shaded zone, you reject null hypothesis. So similarly, you can have a right tail test. The decision criteria remains same if you fall in white region, fail to reject null, and reject null. And yes, please do subscribe to our channel and share with your friends. Comment if you have got any doubt on this topic. And yes, we tried stimulating your thought process to ensure that you understand hypothesis testing well. Thank you for staying connected till end of video. Stay connected.